So in the next few videos, we're going to look at how we can transform circuit elements into the S domain. So let's start with our most simple component, the resistor. And so what we're going to do as we consider this resistor is we want to take the Laplace transform of the IV equation. So let's take our Laplace transform of our resistor IV equation. And so by IV equation, of course, that stands for our current voltage equation. And so we know from Ohm's law, our current voltage equation is the voltage is equal to R times our current. And so the only difference that we have here compared to how you're maybe used to seeing it is I've explicitly labeled voltage and current as functions of time. So what we can do then is if we take the Laplace transform, we can say, well, voltage has some transform V of S. Our resistor is just going to be a constant, so by the scaling property that just sort of goes along for the ride. And then we have our current, I of t, which becomes I of S. So we get something like this. So this was after doing a Laplace transform here. So what this tells us then is that our resistors are behaving the same in the S domain as they do in the time domain. So resistors behave the same in S domain and our time domain. And so what we can do is we can write an equation for our impedance in the S domain. So impedance of our resistor in the S domain is going to be given by Z sub R as a function of S is equal to V of S divided by I of S. So I've just rearranged this equation up here. And of course we can see that's just going to be equal to R. So sort of like we've seen before with doing frequency analysis with a resistor, ideally we don't have any change. And so we can draw what the circuit looks like in the time domain and the frequency domain. And in this case, it's not really going to be too illuminating, but we're going to do a similar thing with an inductor and capacitor. So at least this way we just have sort of a common reference point. So basically, if we have our time domain over here on the left, and we have our frequency or our S domain over here on the right, in both cases, we just have the same impedance of R. So over here on the left in our time domain, we have a resistance of R. On the right, we have an impedance of R. In the left, in the time domain, we have some voltage across the resistor, that is V of t. And we have some current flowing through the resistor, that is I of t. Whereas in our S domain, the voltage across the resistor is capital V of S, and our current flowing through the resistor is capital I of S. So again, nothing too crazy with our resistor. We see it behaves the same in the S domain as it does in the time domain.